In my previous lecture, we have learned the basics of this Microsoft Excel. Continuing with that, today we will be learning how to solve a system of equations in Microsoft Excel. It can be linear, it can be nonlinear. So, let us start with a system of linear equations. So, if your equation is of the form Ax equal to b, where your A is a matrix. So, we will solve them in the matrix form. Say if this is A11, it is A12, A21 and A22. Your x is the two variables x1 and x2, and b is b1 plus b2. Then we know that if your inverse exists, you multiply it by A inverse, the both sides, and your solution is x equal to A inverse b. So, we will be using this technique to find the solution of a system of linear equations. So, let us open our Excel sheet, and here I again highlight, I make the font size a bit bigger, make it 20 and it make it justified. So, the first equation which we will be solving is 2x plus 3y equal to 4 and 3x plus 5y equal to 12. So, the first thing is you write them in the matrix form. So, if I put say capital A, the values are 2, 3, 3 and 5. By x, they are x and y, and by capital B, they are 4 and 12. So, the first thing is I need to find what is my A inverse. So, A minus 1, I give the symbol like this. Since this is a 2 cross 2 matrix, so what you have to do is you highlight 4 cells, 2 cross 2, and in this you just put an equal to. Now, you need to find the inverse. So, the command for that is you click this, you write M matrix inverse. You did not get anything. So, again you retype M inverse and you get this M inverse. Because it is familiar to me, you may try with matrix inverse, but ultimately you will see that M inverse is the command. You give OK. So, N inverse of the array. So, array you will choose these 4. And click OK. But then you see it is only this 5 which is giving, this all are missing. So, what you have to do is, I repeat this process, you take this as highlighted these 4 cells, put is equal to, then your M inverse, it will come, then you highlight this cell close it. Now, to get the answer for all these 4 cells, you have to shift Control, Shift and then enter. So, please remember you have to you have to press the keys, the Control, the Shift at the same time and then press enter, and then you get the A inverse of this particular matrix. So, once you get A inverse, then I have to multiply it by B. So, I rewrite my B here. So, B is, let me put it here, or it does not matter. So, I put 4 and 12. So, this is my x and y. So, it will be A inverse times B. So, I have to now do the matrix multiplication. Again, you highlight this 2 because your answer will be 2 cross 1. You put an equal to, and then for multiplication, the command is M, means matrix. Already it came here, M, MULT. So, matrix, if you double click that, it will come, matrix multiplication. So, you choose this array and shift and highlight all this. So, one of this matrix has been chosen, we call it array. You give a comma and then again come to the second matrix, choose it and then close it. Again, if you want the output, you have to press Control, Shift and then press enter, and you get your answer to be minus 16 and 12. So, you have a linear equation 2x plus 3y equal to 4 and 3x plus 5y equal to 12, and you use the matrix method x equal to A inverse B, where your A inverse exists, and this is how your Microsoft Excel solve the equation. Let us take another one. Say I increase the variable, say x minus 2y plus 3z equal to 9, minus x plus 3y minus z equal to minus 6, 2x minus 5y plus 5z equal to 17. So, the same technique, let me put the value A. So, A is 1, minus 2, 3. This is minus 1, 3, minus 1. This is 2, minus 5 and 5. My capital X is X, Y and Z, and my capital B is 9, minus 6 and 17. So, as before, let us find the A inverse. So, A inverse so I'll highlight this time 3 cross 3. I put an equal to, then type M inverse, here it has come already. I choose this matrix. So, you click, one cell is highlighted, press the shift, move the cursor to choose the whole array. Close it with the parenthesis. Now, to get the answer, Control Shift pressed at the same time and then press enter, and you get the value of A inverse. Okay, so once I get this A inverse, now I have to find the values of this x, y, z, which will be A inverse B. So here I highlight the cell, I put an equality, then matrix multiplication. So MM, this has already come. Then I have to choose A inverse. So I highlight this array, shift and choose this array, give a comma, come to B, choose the array, close. Now to get the answer, Control, Shift and enter. So you get the value to be 1, -1 and 2. So this is the way how you can solve a system of linear equations, whether it is 2 variable, 3 variable, 4 variable, whatever it can be, and you get the solution. Next, let us move to a system of nonlinear equations. In this system of nonlinear equation, we will be using the solver. So let us take an example, say x square minus y plus 2x minus 1 equal to 0 and x plus y equal to 1. Suppose this nonlinear equation we want to solve. I name this expression as f1 and this expression as f2. So I will bring this to this side, minus 1 equal to 0. Now, so what we do first is I need some initial values of x and y. So here is an x. So I format this cell, I make this 20 and justify. Okay. So this is the x value, this is the y value, and I put a f1 here and I put a f2 here. So I have to choose an initial value of x and y. So I will choose, say, x equal to 1, y equal to 1. So if x equal to 1 and y equal to 1 is the root of this system of nonlinear equation, then if I substitute those values here, f1 will be 0 and f2 will be 0. So the idea is to, exactly like the similar one, you first find the value of f1 with x equal to 1 and y equal to 1. Similarly for f2, x equal to 2, f2 x equal to 1 and y equal to 1. So for f1, I calculate the value x square. So x square minus y plus 2 times x minus 1. So the value you got is 1. For f2, it is x plus y minus 1. So both of them becomes 1, 1, and you can easily find out that if you put x equal to 1 and y equal to 1 here, this comes to 1, 1 minus 1, 0, 2 minus 1, 1, and hence 1 and 1. Now, if whatever value of x and y you choose to be the root, the aim is then their f1 and f2 is going to satisfy and they will be 0. So we go to the solver and your objective is you set this value f1 it will go to 0 by changing the variables here x1 and x2. So, C4 and C5, these two. Now, subject to constraint. So, here the constraint is that my F2 is also has to be 0 for whatever changing values of x and y. So, you click this add. So, the moment you click this add, now you have the cell reference. So, this is my F2. This has to be equal to 0, not less or equal to 0. So, I put a equal to and I put a 0 and I put OK. So, now you get the same window again with the objective F4, that is this one, whose value will be 0 by changing the variables this two, x equal to 1, y equal to 1, and subject to the constraint F2 is equal to 0. I remove this, make unconstrained variable non-negative, keep this as GRG nonlinear and solve. Keep the solver solution, and your solution is 0.56 and 0.44. These two are zeros, and as I told you, if you increase the cell size, you get exactly like this. If you want to see them in decimals, right click, go to the format cells, go to numbers, again numbers, increase the decimal point to 4 or 5, and you get this. If you want the same format in the next cell, you have to go to home, you highlight this cell, this will copy whatever format in that cell, and if you press here, this has pasted what has format, both of them give to be 0, and you get your answer as x equal to 0.56 and y equal to 0.44. Now, how to choose this approximate root? Again, I have to do it graphically. So, you take, say, this x value. So, I can start with -5. So, before that I have to rewrite the equation as y equal to x square plus 2x minus 1 and y equal to minus x plus 1. So, those two equations are rewritten like this as a function of y. I put x equal to -5, and this cell I will just add this plus 1, and I will drag this a little, say up to 10-20 values. Now, my first y, I put it y1. y1 is equal to x square plus 2 times x, which is b9. So, sometimes if you cannot find that the cell can be highlighted, you just know that it is b9. So, just substitute b9 minus 1 and you get the value. So, you just drag it up. And your y2. So, y2 is equal to minus x plus 1. Okay. Now, if I want to plot them, I highlight all the cells, I go to insert, I go to this curve and I draw this curve. I can remove because the point of intersection is somewhere here. So, that is why it is desirable that you choose some value between 0 and 1 to get an approximate root. Let us take another example. We are solving the same thing, that is a system of nonlinear equations with a different example. So, now let us take x square minus x plus y equal to 0.5 and y plus 5xy minus x square equal to 0. Now, before using the technique, let us see that how you choose the initial values of x and y. The very first one can be written as y equal to 0.5 minus x square plus x, and the second one y equal to x square divided by 1 plus 5x. So, let us quickly plot these two graphs. So, I have my x values, I have my y1 and I have my y2. Say I put same minus 5 and the next value is this, I give an increment of 1 and I drag to few of them, say 25. So, y1 is going to be, so I will be using this formula 0.5 minus x square plus x, which is a2, and enter. So, you get this to be minus 30, you drag them, get all the values of y1. Then y2 is equal to x square divided by 1 plus 5 times x. Enter and you get this value of y2, you drag and this. Let us visualize this. Go to insert, go to this curve and you see. So, again you have an idea that they lie somewhere between 0 and 1. The point of intersection is somewhere here. So, that is why you choose your initial value. So, let us x and y. Let us again choose that to be 1 1. I have my f1 and I have my f2. So, this whole expression will be f1 by taking this to this side and this whole expression is f2. So, the idea is again the same, that if x equal to x0 and y equal to y0 are the roots of this, then this value f1 and f2 must be 0, because they must satisfy the equation. So, this is equal to x square. So, this square minus x, again this, plus y minus 0.5 and enter. So, you get the value, and for f2 equal to y plus 5 times x multiplied by y minus x square and enter. So, you get these two values, and now we use the solver. You go to the data, you go to the solver. So, if I highlight this now, this is your I2. I have to make the value to be 0 by changing the variables x equal to 1 and y equal to 1. Now, subject to the constraint that I have to add a constraint. So, I have to add the constraint is this f2, this is also equal to 0. I click OK, I get this back. So, now the objective is this f1 value should be 0 by changing the variable x equal to 1, y equal to 1, subject to the constraint f2 is also equal to 0. I remove this so that it is non-negative also are taken into account, and you solve. You keep the solver. So, you see the answer is 1.23 and 0.21, and as usual if I expand this size of this cell, you get that this is minus 1.54 into 10 to the power minus 7 and 8.97 to 10 to the power minus 7. If you want to see them in decimals, you go to right click, then format cells, numbers, again numbers, and change them say to 5. Okay. You can repeat the process here, but otherwise if you want the same format, go to home, highlight this cell, click this brush which is the format, and click it here. So, the same format is transferred here. So, up to 5 places of decimal, your answer to this is correct. You can drag this a little to see, okay, this also gives 6 places of decimal. So, 4 places of decimal you can always take that your root is correct. So, that is how you use this Microsoft Excel to solve a system of linear equations or nonlinear equations. In my next lecture, I will continue this and take it to the differential equations, that how to solve a single differential equation and a system of differential equations with the help of Microsoft Excel. Till then, bye bye.